Okay, here's the TR-4C. We just got the new crystal filters in for it. And there they are, pretty little shiny boxes down there. So, when you mess around in the IF, especially when you change filters, you gotta do a little bit more of an extensive alignment. This transformer here is a filter matching transformer, and so is this one here. And the method that Drake has you do it by the book is pretty tedious and not very accurate. But there's a new sheriff in town. We've got some modern methods and materials. So I'm going to show you how I did that. Carrier oscillator, we reset for the sweet spot between the two crystals. Not exactly 9 megahertz, but close. About 80 hertz low. So, not bad. Anyway, I'm going to use the noise bridge here as a wideband noise generator. And I'm going to tap off the audio line and run it into a little laptop here that's going to run some like a spectrum analyzer program for audio. So let me get this set up so you can see how I matched up the filters. Hang on. Okay, I don't know how well this is going to come across. I have not experimented too much with trying to record off another source like this, but anyway, hopefully you'll get the idea. Let me, that's all out of focus. Alright, well, we'll do the best we can here. The two markers, like I said, are at 300 and 2700 hertz. So 300 hertz here, 2700 hertz here. This is the pass band. It should be relatively level and have nice looking skirts. Ignore this stuff below 300 hertz. It's hum and artifacts of the sound card and the setup and all kinds of stuff. So it doesn't show up in the pass band anyway. I can see my shadow here. Hey. Okay, so what we're looking at now, which filter is that? That's the upper sideband filter. And if I switch to lower sideband, you see a slight change, I hope, in the curve, ever so slight. You might detect a slight change in background noise pitch. But if you zero beat an AM station carefully, you won't be able to tell which filter you're listening through. It's that close. So here's lower sideband, back to upper. Lower. Back to upper. So you're going out a maximum within the 6 dB point of 2700 hertz. That's right here. And you're rolling off pretty much anything below 300 hertz. So your effective pass band here is 2.4 kilohertz. And it's pretty consistent for both filters. See the curve move just ever so slightly. So those two filters are pretty well matched relative to each other. The recovered audio for both lower sideband and upper sideband should be the same, and the transmitted audio for both sidebands should be the same. They should sound the same, or pretty close. I kind of expected these filters to be a little bit wider, but they are what they are. So anyway, next step will be putting an antenna on it. and tune around a little bit. I know that's out of focus, but let me do the sideband switch. That's lower, that's upper, and that's lower. Let me pause it for a second. I don't know if this is any better or not, but lower sideband, 1, 2, 3, and there's upper sideband. Upper and lower. And that's all with the carrier oscillator being about 80 Hertz low for the sweet spot between the two filters. And using my little wideband noise generator that I find all kinds of uses for. So anyway, that's a lot better than using the Drake method. Boy, they you know, they assume you didn't have any equipment, and back in the day, but this is a lot better way to do it, a lot quicker, and you get instant visual results rather than rocking back and forth between the calibrator signal trying to identify the proper peaks to do that filter matching thing. It's really a kind of a nightmare. So anyway, that's it. Next step, put an antenna on it, tune around, get a couple reports. So keep on tinkering. This one's almost done.